In the previous lesson, we learned that our scientists use a system of unit called the International System, and the abbreviation for the name of that system is SI. And we learned that all the units in the SI system are made from the base unit, and there are 8 base units. And from the base unit, we have the derived unit that are made of one or more SI's base unit. In this lesson, we are going to learn the variation of an SI unit. Basically, how do we make different units from the same SI unit? And the way we create new variation of different units from the same SI unit is using the structure of scientific word. And the structure of a scientific word is we have the prefix plus the root and then plus the suffix. We're going to look at more example of this later, okay? But this is a general structure of a scientific word. For the SI system, we are going to focus on the prefix and how we can change the prefix of a SI unit and how we can change a prefix of an SI unit. It will completely change that unit. So it takes another form of a unit. And how we can change the prefix of an SI unit, we would make a completely different unit with different values that used to measure the same physical quantity. So what are prefixes that deal with SI? So here I have the prefixes right here. And this is the name of the prefixes. Below the name, we would have the symbols of the prefixes. In this case, we would have abbreviation or specifically the symbols that represent each of the prefixes. Then, like I mentioned before, different prefixes represent different values. Specifically, the exponent number with the base of 10. So different prefixes represent different values of that exponent right there. But the base of 10 is still the same, okay? Now, the way it works, before we look at the example, one thing you need to realize is by looking at the pattern of the base units, is that the base units are basically the roots of scientific words except for kilogram. Look at the word kilogram. It has a prefix already. So in kilogram, which is the base unit for mass, the root of that base unit is gram. So gram is the root in kilogram. So keep that in mind. And everything else are the root of the word. For example, we have milligram is not the same thing as gram. Because gram by itself, we know it is just 1 gram. Because 1 represents the identity of that particular substance. But when we have the prefix milli, that milli is actually representing 10 to the negative third. In terms of decimal, it's 0.001. So this is actually 10 to the negative 3 gram. So this is a lot smaller. This is a lot smaller than gram. You see now how these two are two completely different units. Then we have grams and kilograms. Then we have grams and kilogram. They are completely different because we have the unit kilogram. The prefix kilo right here represents 10 to the third. That is 1,000. So we have 1 gram for just gram itself. But this right here, kilogram, is actually 1,000 grams or 10 to the third grams. As you can see, the unit represents different values, so therefore they are completely two different units. Let's do some example problem. But before that, let's look at the table again. We have mega 10 to the 6th, kilo 10 to the 3rd, hecto 10 to the 2nd, deca 10 to the 1, the base unit, which is the root, 10 to the 0, and anything to the 0 power is equal to 1. Deci is 10 to the negative 1, centi is 10 to the negative 2, milli, 10 to the negative 3, micro, which is represented by this symbols right there that look like the letter U, 10 to the negative 6, nano, 10 to the negative 9, and pico, 10 to the negative 12. So keep that in mind. I will show you a shortcut to memorize all of these prefixes and their values in the next video. But for now, let's learn how to apply it. So the task is determine the values of each unit in terms of its root. So we basically compare it in terms of the root of that SI unit. And again, we did kilogram already. That kilo is 10 to the third. So we have 10 to the third gram. And we have cm. What does C stand for? C, we look for C, and C is centi. So as you can see, centi is 10 to the negative 2. So negative 2. What does M stand for? Meter. Okay. Then we have liter by itself. Remember, liter is up here as the base unit for volume. So we just have 1 liter. There are no prefix attached to it. Then we have nm. N is for what? N is for nano. What's nano? 10 to the negative 9. So therefore we have 10 to the negative 9 meters. Then we have this symbol with a S. S is for second, as we can see up here. And this symbol represents micro. So micro is 10 to the negative 6. So it's 10 to the negative 6 second. Then we have mole. Mole is a base unit, so it's just going to be 1 mole. Then we have M again. What's M stand for? Milli. And what does C stand for? Coulomb. So we have milli. What is milli? Milli is 10 to the negative 3. So we have 10 to the negative 3 coulomb. And then we have mg. Again, M is for milli. And what's G stand for? Gram. So we have M, was 10 to the third for milli. So we have 10 to the minus 3 gram. Then gram by itself would just be 1 gram. And that's it. So go ahead and do this by yourself. And then check your answer.